All right, guys, Mr. Antonucci here, and in this fourth video, our target is I can find a definite integral using substitution. So in the previous video, we talked about doing indefinite integration, now with substitution. Now we're going to do it with definite integrals. So we're going to learn two methods, and on the AP exam, either method can be used, but lots of times you'll see setups for method number two in multiple choice questions. So the two approaches that we have are, first, we can find a related indefinite integral using substitution, then use the fundamental theorem of calculus. The second way is to find the definite integral directly by making substitution in the integrand and using the substitution to change the limits of integration. Now, that's all fine and dandy, but how does that actually look like? What are you talking about? So for this one, we're going to do method one first. So here, we're just going to do the indefinite integral that's related to the definite integral by the methods that we learned previously. So if we use u equals 4 minus x squared, then du is negative 2x dx. So x dx is going to equal negative 1/2 du. So this integral becomes the integral of square root u times negative du over 2. So we factor out the negative 1/2 and rewrite the square root as an exponent of 1/2. And then you have negative 1/2 um, times 2/3 u to the 3/2 plus c. And then this is going to be negative 1/3 4 minus x squared to the 3/2 plus c. So that's the antiderivative. So the integral from 0 to 2 of x square root 4 minus x squared dx is equal to negative 1/3 4 minus x squared to the 3/2 evaluated at 0 and 2. Okay, so this is going to be negative 1/3 times the function evaluated at 2. If I plug 2 in, 2 squared is 4, 4 minus 4 is 0. That just gives me 0. Then if I plug in 0, 4 minus 0 squared is 4, 4 to the 3/2. So this would be minus 4 to the 3/2. Okay, 4 to the 3/2 is 8, because you can take the square root of 4 is 2, cube it, you get 8. And then times the negative 1/3, distributing to the minus 4 to the 3/2. In other words, our answer is just 8/3. Okay, now that's the first method. Method two, what we do is we find the definite integral directly by making substitution of the integrand and changing the limits. So again, if I let u equal 4 minus x squared, du is negative 2x dx. So x dx is negative 1/2 du. Now, the lower limit of integration was 0. Okay, so if I change it to be in terms of u is 4 minus x squared. So 4 minus 0 squared is 4. And then the upper limit was 2. So u equals 4 minus 2 squared, which gives us 0. Okay, so our integral is going to become the integral from 4 to 0 of square root u times negative du over 2, which is negative 1/2 integral 4 to 0 of square root u du, which is u to the 3/2 times 2/3. Now I'm not going to back substitute in terms of x because I've changed the limits to be in terms of u, which is completely fine. Now I just plug the limits in terms of u. And it might bother some people that the limits got reversed, but that's okay because I did the substitution correctly, the lower limit and then the upper limit. Okay, so I'm going to evaluate this at 0 and 4. So you're going to have -1/3. If I plug in 0, that's going to make that 0. And if I plug in 4, 4 to the 3/2 is 8. This should be 1/3. I just messed that up. So then you would have -8/3, or excuse me, just -8. And then we have distribute the -1/3, and you get 8/3 again for that one. So pretty cool, huh? So remember, when you're using substitution to find a definite integral directly, remember to also change the limits of integration because you will get different answers if you don't, and one of them is going to be wrong. So in this video, we want to do one involving a trig function. So we can first use properties of integrals to simplify before integrating. So because the whole denominator is 2, I can rewrite this as 1/2 integral from 0 to pi over 2, 1 minus cosine of 2 theta d theta. Okay. Then I can rewrite that as I can separate the integrals. So 1/2 integral 0 to pi over 2 of 1 d theta minus 1/2 integral cosine of 2 theta d theta. And here it's still going to be 0 to pi over 2. All right, this first one, the antiderivative of 1 is normally just x, but we're using theta as the variable. So it's going to be 1/2 theta evaluated from 0 to pi over 2 minus 1/2 the integral of cosine 2 theta d theta. I haven't done that part yet. I'm building up to it. So it's going to be pi over 2. All right, so we can actually evaluate this part. It would be 1/2 times pi over 2 minus 0, which is equal to pi over 4. Okay, so this could further simplify to pi over 4 minus 1/2 the integral cosine 2 theta d theta from 0 to pi over 2. All right. Now we're going to keep going with this one. So we're going to use the substitution u equals 2 theta. Du is equal to 2 d theta. So du over 2 equals d theta. Also, when theta equals 0, u equals 2 times 0, which is 0. And when theta is pi over 2, so the upper limit, we'd have 2 times pi over 2. So this is pi. Now, our integral problem becomes pi over 4 minus integral of cosine u, okay, du over 2, all right, times the 1/2 right here. All right. Okay, so the next step, so then we would have pi over 4 minus 1/4 sine u evaluated from 0, from pi to 0, 0 to pi, excuse me. So you'd have pi over 4 minus 1/4 sine of pi minus sine of 0. Sine of pi and sine of 0 both 0. So times the 1/4 is going to give you minus 0. So our answer is just pi over 4. Now, I wanted to show you something quickly on Desmos just to show why you have to change the limits of integration when substituting. So let me bring that over and you can check it out. All right, so let's suppose we wanted to do the integral of from 3 to 5 of 2x square root x squared, oops, x squared minus 9 dx. Now it's 42.6 repeating. Now, just a disclaimer here, you can evaluate definite integrals using a calculator or Desmos on the calculator permitted portion of the AP exam. But you also still need to know how to do them with by hand. Okay. Now, have we done the U substitution? U equals x squared minus 9, then du would be 2x dx, and that lines up perfectly. So the integral would become square root of u du. Now, let me show you something. If I do the limits 3 to 5 of square root u du, I get 3.9 whatever because I didn't change the limits. Now, if I do change the limits, if u is x squared minus 9 and x starts at 3, 3 squared minus 9, so this substituted integral is going to start at 0, and then the upper limit in terms of x is 5, so 5 squared minus 9 is going to give us 16. Now if I do square root of u du, I do get the same answer. Okay, so that's very, very important that if you change in terms of u and you're going to evaluate the definite integral directly with u substitution, you need to also change the u. But be careful, after you get the antiderivative, if you changed the limits to be in terms of u, leave the function in terms of u and evaluate it in terms of u. Don't put it back in terms of x and then use the limits in terms of u to evaluate it. So just be careful there. And guys, hope that was helpful to you. Take care.